Let's talk about what's happening inside of an optical chamber. This is a bare halogen lamp, so it's a tungsten halogen. We've got a very small filament wound over itself in the center, part of what makes a halogen different from an incandescent. I'm going to turn this on. You'll hear the fan that's actively cooling it. Interestingly enough, this isn't a class on heat management, but LED and the qualities of heat sink that happen from LED are important versus traditional halogen or incandescent. Halogen light is pushing heat everywhere versus LED pushes it back, and LEDs often employ heat fins rather than having an active fan, because if that fan dies, then the whole fixture dies. Anyway, we'll put up with the fan during this. So here's a bare lamp, very bright, and you have to control it optically somehow, right? So imagine this in a bare lamp in a ceiling. Oftentimes we just have some kind of a frosted glass lens. This starts to look like a giant light bulb for you. And there are ceiling lights that take this approach with an opal glass lens, something like that. You can also take advantage of the source, and you can add a refractor, which is going to bend the light differently. This is a glass refractor, and you can see it's kind of creating nice cut glass striations around this. Luminaire optics like this can add a decorative feel while still distributing the light. But let's talk about some other distributions that become a little more practical. And to really see how these reflectors are operating, I'm going to add in this shield. So what we see now, instead of the unshielded lamp, we're now seeing distributions of light kind of chopped up. So we have 180 degrees of light here, broken down into, I think, 5-degree increments. I'm going to aim them up and start introducing some reflector technology so we can talk about how it impacts the distribution of light. So this is a circular reflector. It's a half circle cut out. And right now, all the reflections are bouncing from the reflector back into the source. The placement of the source within the reflector is very important. As I shift the circle down, you start to see the distributions of light are now escaping the reflector. They're being projected out into space. So when luminaire designers are creating optics, whether around LED or more traditional lamps, they have to think about how those reflectors are going to shape the beam of light. So circular optics can be very useful for containing light within the fixture. If you're trying to have a decorative luminaire, circular optics can be useful to make sure that the light is being delivered equally. Probably more useful with exterior lighting. This is a parabolic optic, a parabola. And again, placement is key. Parabolic reflectors are used to create parallel beams. So as you see here, regardless of where these beams are coming from, all of them, once I get the placement exactly right, are moved into parallel with each other. That means that this light's going to travel over a very long distance and stay fairly concentrated. Parabolic light fixtures are typically used for searchlights, whether it's the bat signal or spotlights at Hollywood before an opening movie, film opening. Parabolic luminaires are taking and focusing that light to project it far into space. Another one to look at is an ellipse, ellipsoidal lights. Framing projectors employ ellipsoidal reflectors inside of them. So the way that an ellipse has 2 points in space, if you think about the geometry of it, and we're essentially creating the form around those 2 points in space. If I get this in the right spot, all of the beams from this point in space are reflected in this second point. Ellipsoidal reflectors are very important for framing projectors. This is a framing projector steel gobo or steel template. If this is put in the focal center of this ellipsoidal, it'll create a sharp shadow. Actually, it's hard with these, so I'm going to temporarily pull these out so you can see. And the quality of shadow, because it's passing through the center point here, is fairly sharp. If I move that shadow out of the center point, we start to have a blend of shadow. It doesn't have a crisp edge the way it does when it's in the center of the elliptical focus, point of focus for the elliptical lens. So these are all different ways that we control within a reflector. The technology has changed some with LED because this initial halogen model has an omnidirectional 360-degree beam spread, whereas LEDs are actually inherently 180 degrees. They only push light in one direction, which is part of why this demonstration is so effective, that this represents a 180-degree spread. So the techniques by which we would redirect the light are different. That the whole ellipsoidal focus that we had before really depended on backlight into the reflector. Trying to get a point of focus with the LED inside doesn't work the same way. Not that we can't do it, but there are new optical systems designed to take advantage of it. So that's the basics of what's happening inside your reflectors and the way that they pick up and direct the light out of a luminaire.